All right, CalCAB, this is our first AP problem. This is page 35 in your paper binder. So most of you got a paper binder the last day of school before we left for e-learning, and some of you didn't. So you can either find it in your OneNote binder if you'd prefer, or you can find it as a PDF on my Canvas under AP Review. So take a second and read through the whole problem. Realize that this is calculator okay, and when they give you a calculator, you should put that into, you should use your calculator as much as you can. So we're going to take a second and plug that function into y1, and it says these are velocity values for 0 to 5. So there is our function in y1, and my window is 0 to 5. The first question says, find all values of t in the interval 2 to 4 for which the speed of the particle is 2. We know that the speed is the absolute value of the velocity, so I'm going to go to y equals. I'm going to turn off y1, and in y2, I want to do the absolute value of y1. And the question says, find when the speed is equal to 2, and we graph. They specifically said the values of time in the interval 2 to 4, so I see 2 of them right here. For the sake of time, I'm going to only find one of them. So we intersect. Notice that you can toggle between functions, and it's always faster to travel a straight line. So my first value of time is 3.1276. Remember to go 4 decimal places. When you write your response, you need to make sure that you talk about the that's going on in your mind. So we said we want the absolute value of velocity, and we wanted to figure out when that was equal to 2. You don't say anything about y1 or turning off y1. You just put the math right here. So the values of time are 3 seconds and 3.473. Part B. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at time t equals 5. So s of t is the position. The issue is that any integral will talk about the change in position. So we know they've given us that s of 0 is equal to 10. So we can say that the integral from 0 to t of v of x dx is going to be equal to the change in position. So t just represents any random time. Remember that when you talk about the integral, these variables need to be different from this variable right here. S of 0 is equal to 10. Therefore, is equal to 10 plus the from, sorry, I just caught my mistake. So s of t equals 10 plus the integral from 0 to t of v of x dx. Therefore, s of 5 is equal to 10 plus the integral from 0 to 5. We can use our calculator to answer this question for us. So on your home screen, you'll do 10 plus the integral from 0 to 5 of y1. negative 9.2073. But remember that the question asked us for two things. It said write an expression involving an integral that gives the position s of t, and then use that expression to find the position at time t equals 5. So we had to do this part, and we had to do this part to get full credit on that question. Part C, find all times t in the interval 0 to 5 at which the particle changes direction. The particle is going to change direction when it moves from right to left or from left to right. So that translates into the velocity being positive and then negative, or it could be from negative to positive. So in our free response, we would say we need our velocity is equal to 0 and when it changes sign. It's not enough for the particle's velocity to be negative, 0, and then return to negative. That means it's still moving left. Or if it was positive and then 0 and then moving positive again, that means it's still moving right. So you need to have the change in sign specifically. Going back to the calculator, we want y1 back because we want to see the velocities. I no longer need to see the speeds, and I need to figure out when my velocity is equal to 0. So graphically, I see that there are two places in which the velocity equals 0. One is here and the other is here. For the sake of time, I will tell you what those intersections are. Those are your time values. The last question is the speed of the particle increasing or decreasing at time t equals 4? And give a reason for your answer. This kind of question translates into, is the particle speeding up or slowing down? And we know that anytime we talk about the particle speeding up or slowing down, you need to give a twofold argument. So we need the velocity at 4 seconds. And we're also going to need the acceleration at 4 seconds. Remember that in your work, you need to connect what they've given to you with whatever you're using. So we want acceleration, but connect that that is the velocity derivative. So we can use our calculator to do this quickly. Go to your home screen. In your calculator, do y1 of 4. So my velocity is negative. And then you can take the derivative on your calculator at 4. So negative 22.2957. You can also do this on the graphing screen. So because this is the velocity graph, you could say second, calculate the value at 4. So there's your negative 11.4758 like we found. You can also calculate the derivative on your graphing screen. So calculate the derivative and then hit 4, enter. And it says at x equals 4, the derivative is negative 22.2957. So there's two different ways that you can come up with that answer. In the end, you still have to give a reason for your answer. So it's not enough to just write those numbers down on your paper. You have to write your conclusion. The particle speed is up because V of 4 is less than A of 4 is also 0. So that's it. We just did our first AP problem. See you later.